If you observe a random variable a number of times, you will get a data set. So this is the first observation, second, and so on. The mean of this data set will be some value. Then the measure of dispersion of this data set, we have the standard deviation. And it's defined like this. So here we have the observations, and here we have the mean. Then we take the squares here of the distances between the observations and the mean. Then we divide by n minus 1. And here we see a difference from what we had before when we treated statistics. Then we only had n. But now we use n minus 1 because that gives better mathematical properties. An alternative way of writing this formula is given in terms of frequencies like this. So here we have grouped them together, and then we have gotten instead frequencies and different outcomes here. So we have m different outcomes. So it's the same formula rewritten differently. And again here n is just the sum of the frequencies. And then the variance is just the square of the standard deviation. So it's the same formulas but without the square roots. So this is the standard deviation of a data set. Now we look at standard deviation of a random variable. The standard deviation of a random variable we denote by sigma. And sigma is by definition given by this. So we have the probabilities here for the outcomes 1, 2, and so on. And here we have the expectation value. And if you calculate this, for example, for a normal day, then we have that all probabilities are equal to 1/6. The outcomes are 1, 2, up to 6. And the expectation value we have seen is 3.5. So if you calculate that, you will get the expectation value of roughly 1.71. So that means that the measure of dispersion of the random variable x, where x is for a normal day, is given by 1.71. But what does this mean? That means that if you do many observations on x, you will get a standard deviation close to this one. And if you do it infinite many times, you will get exactly equal to that one. So the standard deviation of a random variable is the standard deviation of a data set you get in n observations when you do, in the limit, infinitely many observations. And the variance is just defined as the square of the standard deviation. So standard deviation and variance are basically the same concept, just differ by a square or square root from each other.